stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hi, I'm Leandro Facchinetti. Let's write some code together, shall we? What we have on the menu today is to continue our JS effects library. It feels like it has been a while. We are working on this JS effects library that is going to help you develop good-looking, easier to use audio effects with real-time processing in REAPER. And what we are going to do today on the library is drawing waveforms. Similar to how when you have an item on the timeline, let's have an item on a timeline. I think there will be an item here, yeah. So similar to how when there is an item on the timeline, you can see the waveform for that item. We want to do something like that in the real-time audio effects because we can show the effect that, well, what's happening on the waveform. So if it's a compressor, you see the peaks going down, and if you know what I mean. So yeah, drawing waveforms. And I started this several times actually. We have been kind of on a spiral. We are getting somewhere, but sometimes we take the wrong turn. And I think that this was a wrong turn. So I started implementing a rectified version of the waveform. I think I better have data structure and just store all the data for the full drawing of the waveform and give the rectified version as an option. And in case you don't know, let me show you what I mean by rectified and not rectified. So let me go to the view. Yeah, here, peak display settings, and this is what rectified waveforms look like. You just take the absolute value of the number instead of letting the number be between 1 and -1. So I think that we should, in some effects, have a way to show rectified peaks or non-rectified peaks like this. And if we want to store non-rectified peaks like this, we need to store the maximum and the minimum. But if we want to do the rectified peaks, we just need the absolute value. So we need to store more information for the non-rectified peaks. And here I am just storing information for the rectified peaks. So it means that if I do it like this, then you will not be able to toggle between the two. You will have to decide, and by you I mean the developer using the library, not necessarily the end user of the audio effects. But the point here is the developer using the library will have to decide beforehand if they want to have rectified waveforms or not. And if they decide to use rectified waveforms, they cannot use the other one. But if I don't use the rectified version, if I just store all the information I would need to draw this, you can switch between the two. And maybe in your effect, you are only interested in rectified waveforms, so it would be wasting a little bit of space, but I think that that's okay. It's better to just have this flexibility. It's not too big of a deal. It's just ignoring some pieces of data. So the first order of business is to remove this whole rectified situation here, because we will store all the data for both, and then it will be drawing option, whether you want to rectify the waveform or not. So this is the duration of the waveform that you want to store. Because we are processing the audio in real time, we don't have the luxury of looking at the whole item like this. We will only see a window into that time. So maybe something like this, and then that window will keep moving. as new samples come in. So this is the duration of that window. It's going to be a window that is going to hold 5 seconds worth of audio, for instance. So that's what this is. This is the number of samples on each slice. So the way that the waveform drawing is going to work is I will have slices, and the slice is like one vertical bar here. You can see that because there are so many samples, in this case here, we are not seeing a line. We see sort of a blob. It's a shape. And maybe this color doesn't do this any favor. So maybe this will make it easier to see. It's like a blob. So a slice is one vertical line here. And this vertical line has to store the maximum and the minimum value because the width of this line changes. You can see that it's somewhat thinner here and thicker here. So I will store this, what I'm calling slices. They are vertical bars that make up the waveform. And I store it this way because you may store like 10 seconds worth of audio to show something. Maybe. 10 seconds worth of audio is a lot of samples. It is 480,000 samples on a regular sampling rate. So that's a lot of samples, and we don't need that many samples to do the waveform drawing. We would need that to do some sort of oscilloscope display where we show every sample. But that's not what this is. You can even see that in Reaper, it sort of stores these peaks in different ways. Probably there is a way of, like, I am guessing here, but probably they store in the peaks file. Because for every audio file, there is a corresponding peaks file here. And what they store in there is the information that they show up here. And I believe, just guessing, but I believe what they store in there is they store a high-level version like this, which is what we are interested in doing. And then maybe a second version like this, which with more granularity. But then you can sort of, as you zoom in, you'll be able to see when it switches from this mode into the sample mode, which is right about here, see? So this is a different drawing mode, and that's not what we are doing. We are doing this high-level view. And that means we don't need to store as many samples, we just store the slices. But we do need to know how many samples we are going to store on each slice. This is something that we can compute based on the number of slices, which is this number, and the duration that you want to store. So if you want to store 10 seconds, that will be this many samples. But if you only need, like, let's say 5,000 slices, because you guess that the display of the waveform will not occupy more than 5,000 pixels. So it's really not worth storing more than this. So you can see that we are saving a lot of storage space here. We are saving, well, this number minus this number, which is a lot. But this number of samples in slice is how many samples are we going to store on each one of these slices. And in this case, it is going to be that many samples, 96 samples per slice. So that's what this is. This is telling me how many samples I'm storing in each slice. Then there is, as I am building up a slice, as samples come in, I'm accumulating samples into a slice. That's what this is. This is a place for me to temporarily store a slice before it goes into the slices circular buffer. So the purpose of this is just, it's a circular buffer, so as new samples come in, I will be able to push more things and the older things will fall out. We'll forget about the old slices. And so this is going to be a circular buffer, and this is going to be what we add into the circular buffer when the number of samples in the slice has been reached. So that's what we have so far. But I think that we need to change this because the slice has a maximum and a minimum, the top and the bottom. And I could store this in different ways, but I think it just makes more sense for me to have a maximum and a minimum as two different fields. And in the past, I played with the idea of having a data structure to represent a slice, and then I would store data structures in the circular buffer. I think that maybe that was too much, abstraction. It would probably make things slower because we would have to access memory in more places. Didn't simplify the code a whole lot, so having a maximum and a minimum, if it was like 5 fields, maybe. But in this case, a slice is just 2 fields, so it's good enough to just put this here. So now also the slices will need to have a maximum and a minimum. And then we have 0, 1, 2, 3, 4, 5. We end up having 5 fields on the waveforms data structure. And another thing that I'm thinking about is if I want to use the circular buffer, sort of re-implement the circular buffer strategy over here to inline the data structure, making it faster. But I think that using the honest to goodness circular buffer will be good enough. And we do have an implementation of the circular buffer that is even tested and everything. And it is supposed to be fine, it's supposed to be working. So yeah. So now let's see how you create one of these data structures. You will have to make 2 decisions when you create the waveforms display, the waveforms data structure. You need to give me the length of the slices array or circular buffer, because I will need to allocate that memory, and you need to give me the duration that you want to store. And I have these 2 in reverse. I wonder why. Probably you want to have something like this. And do I want to make any of these 2 a default argument with some number? We may. Because the number of slices is something that has to do with the size of the screen, right? I will need more slices to fill up a larger screen. And I believe that we made this in the past, we made this decision in the past, and it kind of works well, I think, which is just look at what is the width of an 8K display. It's this. So if we store 8,000 samples, it will be good enough because it can fill the width of an 8K display. So we'll have a default here. And in this case, I will only ask for the duration. This will default to 8,000. That's where the name 8K comes from, isn't it? 8,000. So next, let's do the actual allocation of this object. The array will have 4 positions. That's wrong. We now have 0, 1, 2, 3, 4, 5. So we need 6 positions. And then we need to initialize all the positions. Right, so the duration is simple. It's actually here. And then samples in slice is a counter of how many samples I have in the slice that I'm building up to. This slice that I'm building up to. So yeah, it starts at 0. Then the maximum slice, I will have to reset to something. I will reset it to infinity, but now I need to think about if I want it maximum to be positive or negative infinity. I think I want it to be negative infinity. Well, the minimum will default to infinity. And then I can take just the minimum between the current minimum, which will be infinity to begin with, and the value that comes in. That's great. And then this will be two circular buffers, just like that, with a given length. Right, I think that's all we need in terms of allocation. And then we return that data structure. Then let's look at how it happens when, let's look at what happens when we push into the waveform display. We will need a waveform and we'll need a sample to push in there. Then we'll have some local variables, and this is clearly where I stopped. So let's remove this code and think about what we want to do. Well, we want to check, well, I guess we want to accumulate the sample into this. So let's have the minimum and the maximum, and we are going to set new values for minimum and maximum. It will be the maximum between its current value and the sample, and the minimum is going to be the minimum. So that's accumulating the sample into the current slice. Then we need to check if we went over and we want to put the slice into the data structure. And yeah, we'll put the slice into the data structure and reset. So let's think about how that will work. We'll do something like this, and we need to look at the function that pushes data into the circular buffer. Let's look at the functions that are available on the circular buffer. You can instantiate, you can push, and you can get. That's pretty much all you can do for now. Great. So this is what we need to call. Oh no, this is the get function. This is what we need to call. And naturally, we want to call that with these variables. And the value that we are pushing, we'll look at that in a moment. So that's how we push a slice into the circular buffer. But of course, I don't want to do that all the time. I want to do that only when this samples in slice has been reached. So let's look at this, how it needs to be updated. We do have a notion of circular counting. It's this. So you can just use this version. And the circular counter in this case is that, and the maximum is I think I am missing something here. Yeah, I'm missing, I have a counter, but I don't have a variable to hold that division that we did in the beginning. Yeah. Yeah. Zero, 1, 2, 3, 4, 5, 6, great. And then we need to allocate 7 positions. And then the default for, or not the default, the initial value for this is the duration divided by the length. So if my duration is 408,000, 80,000, and my length is 8,000, you'll get that number over here, that division over here. Great. So now we can check against this. And just to refresh my memory, this circular counting situation is going to return the new value, right? Right, that's what it does. So next, so we have updated this. And we need to check if we wrapped around. We need to check if, yeah, we will need to check if we wrapped around and if it's time for us to do this. And one way we can do that we cannot check for 0 because this maximum here can be a fractional value, right? This division doesn't have to be an integer. So here we will have a value that may not be 0. But it will always be less than 1 because that's our step. So we can do something like samples in slice less than 1. That means we wrapped around. I think that will be good enough. There may be enough by one mistake in here, but because it's such a small mistake, no one will notice. So I think that's all we need. We are computing the new slice and we are wrapping things around when necessary. Great. So now let's just declare all the local variables and we'll be on our way. My multiple cursors are giving me a hard time here. Now we got it. Okay, and naturally we will need to get all of this from the waveform. So we'll do lines that look like this. And we also will need this, which will need to be a local variable. So that and that. And there are some things that we need to update at the end here. And what do we do in terms of pushing into the circular buffer in terms of the return value? It returns the value that you pushed. So I think it would be a good measure for us to do the same over here. Not that it matters, not that you should be relying on this, but it doesn't hurt. And then, yeah, we need to update some of these things. So the minimum and the maximum may need to be updated. Oh, I'm forgetting to update them. If I wrapped around here, I will need to do this. Yeah, in this order. First I want to store it here, then I want to do that, to reset it. And then there are some things that we want to update. So these may have been updated. Well, they of course, they for sure have been updated. This has been updated potentially, but this is not. So we can do it like this. Okay, so this is what you need to do to push a sample into the waveform. display. Now let's do something that will actually draw this. I will need the position, the dimensions, and possibly, if you want to be able to zoom into the thing, a scale. But I will not do that now. And also, I kept going back and forth with the idea of passing colors into this. Let's see what I'm doing to the rounded rectangle feel. I am passing a color, like this. And over here, I'm also passing a color. So I guess that's the pattern. So I'll also ask you for the color that you want to draw this waveform in. And then we are going to do that traditional bit that I sort of implemented this many times in the stream already, but I will implement it from scratch again because we changed the data structure so much that I think probably any code that I have will not really work in this context. So what we do is we start from the right because our circular buffer goes to the past. So we'll have an offset that will start at 1, then we'll loop for the number of slices. So we will need to get one of these and get its length. Yeah, essentially this variable. But it has been embedded in one of these guys. So I'm getting from there. And then we do offset plus equals, or minus equals 1 actually, because we are going to the left into the circle buffer. And then we are going to need to get the minimum and the maximum. So I'll call this a slice minimum and maximum. And we'll need to use the circular buffer function to get. What is this circular buffer? It is slices, then minimum and maximum. Just like that. Then we need to position ourselves to do the drawing. And this is where you ask, this is where I have the option to make it rectified or not. So let's not worry about this for now. Let's do the regular thing first. So I need to position the cursor. I will need to draw a rectangle. How do I draw a rectangle in JS Effects? Like this. So I will need to define these X and Y things. Over here. And then also the width and the height. But they are not the same from here, because this is the width and height and X and Y of the whole component. So we are going from the right. So I'll call this the waveform X. Or maybe the X index. It's not really an index. I'll call this the waveform X. Whatever. Or maybe draw X. Yeah, that's good. So it starts on the right, which means it's X plus width. And that's where I want to draw. Then the Y I'll get to that in a moment. The width will be 1. Let me get from the design system. I think there is space 1, right? Or there is space pixel. I think I'll do that for now. And it may be silly, I could just be passing number 1, but it's not as silly as you may think, because this also takes care of retina displays. And then the height. The height is easy. It's the maximum minus the minimum times the height. No, not quite, because maximum is a number. Maximum is a number between -1 and 1. Minimum is a number between -1 and 1, which means that the subtraction of the two may be 2. If one is 1 and the other is -1, there may be 2. So I need to divide this by 2 before I multiply it by the height. And I also need to take the maximum between this and 1. I don't want this to overflow. I don't want to draw beyond the boundaries of the component. Right, so this takes care of the height. The width is also good. Then this I will want to update every time I go around the loop. So it becomes sort of one of the loop variables. I think it's the secondary one, so I'll do it like this. And then we have the offset, which starts at 1, and then we have this. And then we need to update this to go to the left. So we need to calculate what is the increment that we want to apply here. Let's have that. It's going to be called draw x inc or decrement. Yeah, decrement. No, I'll call it increment because I want to subtract, because I want to go to the left. So, or maybe even slice width. That makes more sense. And what is the slice width? It's the width of the whole component divided by the number of slices that I'm going to draw. Looking great. Probably this is becoming too much for one line, so let's break it apart. All right, all of this is looking good, and then we only have to compute the y. The y is only related to the maximum. Hang in there, do I have all my... Do I have my coordinates wrong? No, I don't think so. Yeah. I want the y to be in the middle of the component. So it's going to be the y that you gave me. Let's get a midpoint. Let's have a midpoint situation. So we'll have a y midpoint, which is y plus the height divided by 2. That gets me the midpoint of the thing. So I'm going to start there. And then I will subtract the minimum. No, the maximum. I'll subtract the maximum because the maximum is at the top. So I'll subtract the maximum. In other words, coming back here to this example, this would be 1. This would be -1 in the drawing. So right here is our y midpoint, and we want to subtract to go to the top. something that is based on the maximum value, because the maximum is over here on the top. And I want this height divided by 2, height half, and again, I think I may need to divide this by 2 and take the maximum. Or actually, I want the minimum in this case. Yeah, in other words, if it clips, I will get just 1, and then I will divide that by 2 because I will multiply by half of that. Does that make sense? Maximum is a number between -1 and 1. If I divide by 2, it's between -half and half. And if I multiply this by the half of the height, I will not get to the full height. So in this case, I either have this division by 2 or that division by 2, but not both. So I think I will have this one. And I think that that does it. So let's put some new lines here to make this easier to look at. And maybe we will have some auxiliary variables here just to make the whole thing easier on the eyes. This is not dependent on anything else, so I can pull it up. But this is dependent on the slice. Okay, and now let's review and assign all the local variables and take a look. So what do we have here? We are setting the color that's necessary for this to work. That's great. Then we are going to determine the slice width, which is the width of the whole component divided by the number of the slices, which is how many times we are going to draw this, so it makes sense. Then we start the offset at 1 and this. So these are the loop variables. They should be here. Half of the height, that's easy. The drawing width. Okay, I want to have that here. That makes sense. The Y midpoint also makes sense. Then the offset is one of the loop variables. We start at the right of the component, so add width and add a slice width just because we want to be able to subtract it later. Then to do the looping, I'm going to loop over all the slices because I want to draw all the slices. Then I will do this to update the loop variables. Then I will do that to get the slices or the slice that I'm about to draw. Then to compute this, this is the Y, it's the mid position minus, so it goes up. This number, I am limiting the number to be 1 so I don't draw on top of the component, times half of the height of the component. Then to draw the height, the height of the thing that I'm going to draw is, I don't want to take the maximum, I want to take the minimum. I think that there is still a chance that I am drawing below the component. Oh, Bo is here. Hello, Bo. Great to have you. How's it going? It's been a while. No, actually, you were here yesterday, but we didn't talk much. So, I am good. I am good. How are you doing? How are you feeling? Yeah, there is a chance that I'm drawing below here. There is a bug because I'm not taking into account the Y position as I do this minimum situation here. So yeah, there is a bug here. I'll just take note. Fix me. We should take. So I guess it's a good thing that I gave these things names, right? Because now I'm using the name. We should take that into account to prevent drawing below the component. Well, we should take that into account when computing draw height. To prevent drawing below the component. So we take the subtraction, we divide by 2, we take the maximum, blah, blah, blah. All of that seems good. Then we do this to actually draw. So this stands a chance of actually working. Let's extract the local variables and try to use it in a real effect. What do we have here in terms of local variables? All of these are local variables. Then this has already been defined. These two are new local variables. This is a new local variable. That is a new local variable. And then I have to create here an effect to test this. I could just use tests, but let's not. Let's copy this into Waveform. And I'll call this Waveform. And then we don't need to run the tests. I will want to keep this. I will want to keep that. That seems okay. The background can be that. And then we can call the waveforms. Oh, I will need a sample block. Oh, and I will need to allocate the data structures, right? So let's have a waveform. Or maybe let's do multi-channel, because why not? It's so easy. Yeah, we'll do that. And Bo is saying, Lols, I was migrating my website to a different hosting. I watched the yesterday's streams today. I am pretty sure you were on the chat yesterday. Really could have used your help migrating the site. Oh yeah, sure, I can help. Just let me know how. Waveforms is going to be a list of... it's going to be an array. No, it can be just a chunk of memory based on the number of channels. And then we are going to loop over all the channels. And then we are going to set into the channel a waveform new. And I'm only going to give the size. I'm just going to rely on the default of 8,000 slices. So I'm only going to give the duration, I guess. I will need to convert from milliseconds to samples. And let's store 5 seconds. Then that's all I need, actually. This is good. Then we'll do a loop similar to this, except that we'll call a different function. We will call this. Nope, we'll call that. And as the waveform, I'm going to pass this, and as the sample, I'll pass that. Then for the actual drawing of things, we will do something similar to that, except that the channel variable has to be namespaced because these two blocks run at the same time. And then over here, we'll not call push, we'll call draw. And the drawing function receives a bunch of parameters. All these parameters. This first is easy. It's that. That one is easy. Can be a 0. Y. Y has to be something else. So Y will start at minus Y increment. And Y increment is going to be GFX height divided by the number of channels. And then we are going to need to update Y. Just like that, so that's okay. The width can be the whole width, the height can be the whole height, and let's draw in a nice 200. Okay, let's see. Oh, your website was due yesterday, and did you do it? How did it go? Do you want to like maybe share the link and we can all take a look? That could be fun. So let's, in this track, let's drop the waveforms. That, let me check again that, yeah, master, it doesn't have any outputs, but I'll mute it anyway. And then we have that, and it is not showing much, but that's probably good because no syntax errors, but no drawing either. What the hell? What's going on? Channel is 1 and number of channels is 1. That doesn't seem right. Also, it doesn't seem right because I have 2 channels. Oh, but they are channel 0 and 1. Oh, come on. And then length. Length is a stray variable. It should not be here. And all of these are actually, all of these guys, they are internal variables, so I forgot to specify them as local variables somewhere. Let's chase this first one. Length. I bet that it is on the waveform display, right? It could be also on the circular buffer or somewhere else. Yeah, let's look at tests just to make sure. Length is a stray variable here as well. So it could, it's not on the waveform display. It could be on the circular buffer, for instance, or somewhere else. Just let's search for a stray length. That's all right. That's all right. We probably have something like this. So let's look for that. Yeah, here we are. Length. And then that's that. Okay, so we can retest. All right, position and version. Position is a stray variable. It's not here. So let's look for position. And it's here as well. And now no stray variables. Great. Version it's there. So belongs to the effect. Then waveform, more stray variables and weird things. GFX channel makes sense. Slices are leaking. Waveform makes sense. Y makes sense. Though I probably want to namespace all of these guys as well, just because I may have the Y variable in the sample block and I don't want to have to remember which variables I have already defined. So I established the convention that all my local variables in the GFX block will be namespaced. But I doubt that that's going to solve anything. Bo says, well, it's the same old one and it's down now. That's how well it went. Oh, I'm sorry to hear that. Yeah, things are complicated. Now we are chasing for slices leaking. So let's look for slices. Not here though. Slices and slices maximum. Oh, isn't that interesting? It only occurs here. Oh, these guys. I have not collected them. So they are going to be local variables. And they are going to be local variables here, I think. No, actually after they slice. I try to put the variables here in the local block in the same order that they appear in the actual code. So now we need to assign to these guys. And what are they? Well, they're simply in the waveform, so I can just collect them. Just like that. And I think, though, I could do it here and that would save me 2 memory accesses for every push. But do I care about that? I think I do, because this is going to run in the sample block. So I'll leave this there. I'm scoping the variable because I will not need these variables if I am not wrapping around. Okay, so I guess this was a big bug. This could have explained us not seeing anything. Let's try this again. Well, I'm not running any audio through this. Well, still not getting anything. I will leave this looping. Yeah, it's on repeat. I will leave this looping so we always have audio running through the effect. And then let's look at the variables to see if there are any other stray variables. Slices maximum, length, and all of these being zeros could explain the problem. So let's look for them. Oh, here we have the same issue, I guess. Yep. Same issue. I just forgot to retrieve the variables from the data structure. And when I'm drawing, I just access things, so I'll not need to write anything, but I will need to read a bunch of things. Yeah, so let's look at the variables that I'm using and see. For instance, this one, I haven't collected this variable, so I need to do that. I think what I need to do is take this first. So I have the slices maximum over here. And maybe I could rename this. Doesn't have to be the maximum. It can be just slices length, because that's what I called it over there in the constructor. But I will need to get it from the maximum. So I'll do it like this. And then So this gets me the maximum, then I will need to get from that the length. And this is that, which is a variable. Right. And the next is the slices maximum. Oh, look at that. I accessed that twice, so I might as well just copy things from above. Looking good. Then I think I have everything. So let's give this another try. Who knows? May work this time. Oh, there you go. Haha, it worked. Great. It's cutting off at the bottom, but just because I resized the window? No, not because of that. Because there is a bug. That's progress. I will commit to these changes. We wrote a lot of code today. And it's not looking too dissimilar to what we have here, right? If I put these two next to one another, doesn't look too bad. And it seems like this one is rectified, but no, it is just a bug somewhere. And even this is kind of too low, so I wonder if I just made a mistake in the thing that calls this. But no, it doesn't seem like that. No, it seems like it's correct. Oh, hang on. This is not right. It shouldn't be the height of the whole thing. It should be the height of a channel. So GFX channel height, or even waveform height, is equal to that. And then that, and then that, and full compile reset, error compiling. Why? Oh, semicolon. Shout out to Aria. Full compile reset, and there you go. Let's unloop. And this looks like an honest to goodness waveform display. I'm happy. This looks good. And I guess now we are back to where we were when we started this, right? Because this is not the first time we have been on this whole waveform display hill. We have died here before. Next, tomorrow, I guess, tomorrow I am going to do the rectified version, some other improvements. It will be fun. That's the plan. Tomorrow, rectified version of this and maybe some other things related to this display. Oh, let's watch this as it goes away. Awesome. And this was mono, but this is... Oh, it was not mono. It was stereo to begin with. But this effect is stereo. It doesn't have a way of knowing that there is only a mono item here. So even if it was a mono item, it would show two waveforms. You probably want to show a line in the middle, just like this, even if there is no sample coming in. So yeah, plenty of things to improve on this waveform display, but it's back using the newer version of the library with the new conventions that we are establishing. So not bad. We wrote like, 2 pages of code today. Yeah, so thank you all for being here. Thank you everyone else who was here. And thanks for the support on Patreon and PayPal. And look forward for tomorrow when we'll be back to this more waveform displays, rectified version, other good things. Take care. Be safe. I see you tomorrow. Bye.